Okay, let's do an example for related rates. Here we have a spherical balloon. Air is pumped into it with this rate, 50 cubic centimeter per second, and the question is find the rate of increase of radius when diameter is 60. Well, first identify the variables. Here we have volume and we have the radius. So we denote with this guy with V, we denote with this guy with R. Which one or what kind of rate of changes are given? So we know that the air is pumped into sphere. So it means that that rate, that is the rate of change of the volume of the sphere. So in this case is 50 cubic centimeter per second. And then the question is how fast. How fast means what is dr dt when the diameter is 60. In other words, when diameter is twice as radius. So when r is 30 centimeter. So here, then, what we do start finding the relation between the variables. We know that the volume of a sphere is 4 pi over 3r cubed. And to find so V and R are related through this equation. To find the relation between the related rates, we find the dt of both sides. That will give us the relation between the rate of changes. So in this case, we have dv dt is 4 over 3 pi d r cube dt. And this means dv dt is, this 3 comes down, this is 4 pi dr dt r squared. We are using the general power rule here, and that gives you the relation between the rate of changes. Now we want to plug in everything in and find this dr dt when we know what is dv dt. Here you notice that since we have r still in the relation, that's why we need to know at what point, meaning that it means that when r is different values, the rate of change of a radius will be different. So plug in the values. And this gives us 50 equals to 4 pi 30 squared dr dt. And from here, we can just go ahead and find dr dt is 50 over 4 pi times 900. And that's enough. This is a good number. You can simplify a little bit. For example, you can write 5 over 360 pi. But that's basically what we have. So the radius increases at this speed, 5 over 360 pi centimeter per second.